Hello everyone, in this video I will be giving an overview of the bachelor thesis topic titled A Web App Network Emulator for Capacity Planning of LoRa Networks. So LoRa networks are long range, so LoRa is a long range communication scheme. And because of the long range of communication of LoRa, then it will be supporting dense IoT networks. So over here you have an example of a gateway or a base station where you have hundreds of thousands of sensors that will be sending data towards this base station. Now LoRa uses the Aloha protocol, and because of the Aloha protocol and its simplicity, then collisions will be inevitable, and the question is usually what is the expected capacity of this LoRa network or of this particular gateway. So how many IoT devices can it support? To answer this question, we can do it experimental, which means that we will experiment with different devices, but this is not practical because at the end of the day, we can experiment with 1, 2, 3, 4, 10, maybe 100 devices, but we cannot reach the scale of hundreds of thousands of devices as it would be very costly. You cannot install the system and then check whether it will work or not. The second approach is by simulation, which means that we build a computer model that will simulate the arrival and departure of, or the arrival of packets and the sending of packets and the collision events. But this is not necessarily accurate in assessing the real reception capability of the gateway, because what we usually do in simulation is that we put some threshold. So we say if two packets arrive at or overlap, partially overlap, then we call this a collision and both packets are dropped. This is a simulation point of view, but practically this might not necessarily be the case, because we might have a close IoT sensor and a far IoT sensor that send at the same time. So this is a collision. However, because the sensor that is close to the gateway has higher power than the one that is far away from the gateway, then the receiver will be able to decode the signal. You can think of it that you are talking to someone, so two people are talking to the same person, one with a loud voice and one with a small voice or an unhearable voice. Then this is collision. However, the receiver will be able to understand what the person with the loud voice is saying. So you can think of it of the same way. So the question is, can we do both? And in the idea of the emulator, which we have built, yes, we can do this. How do we do this? So we have already built the emulator itself, and we want to build in this project a web app for this emulator. So what is this emulator? The emulator is composed of replacing the devices that you will create by a simulation, okay, and sending them from a software-defined radio device. What's a software-defined radio device? Software-defined radio means that you can configure the transmission power of and the transmission signal of this device by software. So the idea of the emulator is that we will build a simulator to simulate the arrival of packets, to simulate the power transmitted by the packets, but rather than assessing the collision from the perspective of the simulator, what we do is that we will actually transmit the signal. So in your simulator, a new packet arrives. So we simulate for it a random location. In this example, the sensor is located in this location by the simulator. Based on its location, we can compute its transmission power. And then we actually physically send the packet, the real LoRa packet from the software-defined radio towards a real receiver. So this is a compatible LoRa packet, and this is a real receiver. Now in my emulator, so now it's called an emulator, I have another device. So in the next packet, maybe let's assume that this device is closer to the base station, and therefore the transmission power needs to increase. So when we compute the transmission power over here, we simply increase the transmission power of the software-defined radio, and then we send it to be received by the practical LoRa gateway. So the emulator is composed of a software-defined radio, a Python code that is used to simulate the arrival of packets and the required transmission power, and then this is sent to the software-defined radio to be sent physically, and we have a real commercial LoRa receiver to receive the transmitted packets. And now the capacity could be more practically assessed by answering the question is, of how many packets have we correctly received by this real gateway. So this is the idea of the emulator. Now the objective of the project is to have a web interface for this emulator. So we have the emulator, it is working, and we are able to send packets and receive packets by the LoRa gateway. And we want to develop a web interface for community for studying LoRa networks. So think of it that we will put this over the internet. Anybody interested in the topic of the capacity of LoRa could access our website and input to us the number of devices that he wants to simulate, the traffic and the application profile of their system. So the traffic profile means what's the arrival rate, the application profile, what's the packet size, and what is the type of the wireless environment they would like to simulate. So it's an urban, is it a suburban? What are the LoRa parameters that they want to consider? So there are different parameters, like something called the spreading factor, something called the bandwidth that is used. What are the parameters they want to use? And your emulator will take this data, run the Python code along with the software-defined radio, and then it will expect the output results that will be reported over the web app, telling the user what is the number of successful received packets, what is the network capacity, and you can have other statistics like the receive signal strength distribution and other things as well. What are the tools that we will be using in this project? So since it's a web app, we will be using HTML5, and you will also need to be familiar with Python because you will need to interface with our existing Python-based network simulator that we're using to communicate with the software-defined radio device. So this concludes the overview of this project. Thank you very much.